That'd be kind of annoying, wouldn't it? Well, how you there? How you doing? I'm ready to rock and roll. Here we are, Unit 11, Day 3. Sequences and series. We're getting down to the end, and I'm getting just a little bit crazier every day, just a little bit crazier. So let me put my name on the paper. Okay, let's not have the paperwork. Now we're in day 4. That's next. Day 3. Go up here. Draw. We're gonna let me write. Mr. Krause. Yee-haw. Here we go. Let's see. Function notation. This is just a little warm-up. Little bitty warm-up. Function notation. You guys know how to do this, right? Function notation. F of x equals... Pen's not working so great. Maybe you need some coffee. So all we're going to do is plug in 0. So in this case, this is not working great. Not working great at all. Wonder why. And sometimes it works fantastic. So f of 0. We're going to plug in 0 squared plus 6 times 0 minus 8 negative 8. Whee! F of 1. I'm going to plug in 1. 1 squared plus 6 times 1 minus 8. What's that? 1 plus 6 is 7 minus 8 is negative 1. And then we'll plug f of 2 in, and we get 2 squared plus 6 times 2 minus 8. Let's see, that's 4 plus 12 is 16, so this is like 8. Something like that. What do you think? Not too bad? And then I can come over here with g of x. Do g of 5. We're going to do 3 times the square root of 5 minus 5. Stuff's pretty simple, right? That'd be 0 because this is just 0. Whoosh, gone. And then g of 10 would be 3 times the square root of 10 minus 5, which is just really equal to 3 square roots of 5. That's all you can do with that. And then you got g of 15. So it's just function notation. That's all we're doing. Function notation. What do you think? Wouldn't it be nice if today's stuff was just kind of simple like this? It is. So, this is 3 square roots of 10. I can do the same thing. Now I'm going to use the function a. Oh, that's weird. I don't know if I've used a before. Oh my gosh. I'm going to do like 2. A of 0. Because that's easy. 6 times 0 minus 2. Well, that's just negative 2. And then a of 2 is 6 times 2 minus 2 equals 10. So, kind of simple. That's function notation. You're used to that. You're okay with that. You're comfortable with that. This notation where we have a and then we have a subscript n is not as easy as what you've seen in the past. We're going to create a sequence of numbers. So this is kind of like a formula that will generate a sequence of numbers. So I would like to know what the 10th term of the sequence is. So all I do is say, okay, a sub 10 is equal to 10 squared minus 1. Well, that's 100 minus 1, which is 99. Or I can do the 20th term of this sequence, or 20 squared minus 1, which 20 squared is 400, so this would be 399. Or I can do the 30th term of this sequence, and I get 30. So you'll see that it's kind of similar than function notation. So I got this thing called finite sequence, infinite, otherwise known as infinite sequence, and then we got a rule for sequences, or a sequence rule. So a finite sequence ends. It is a sequence that has a finite, I know I hate to say it, has a finite, or otherwise known a certain number of terms. It ends. That's it. An infinite sequence has, oh wow, here's an infinite number of terms. Doesn't end. Does not end. Okay. And a rule for a sequence is really we're just going to create some type of an equation that kind of spells out how to create the sequence of numbers, where the domain is, in fact, the set of all natural numbers. It's just the counting numbers, because your first term will always be a sub 1. Your second term will always be a sub 2, then a sub 3, then a sub 4, then a sub 5. So we're really just plugging in a 1, plugging in a 2, plugging in a 3. So that's your domain. It's the series of natural numbers. So, for example, in this case, I could to ask you for the first 6 terms of this sequence. Well, you would say, okay, the first term is f of 1. Right? And then I'd go f of 2. And then I would go f of 3. And then f of 4. And then f of 5. And then f of 6. Now, if you actually had to put all those in, although it wouldn't be too bad, it certainly is a lot nicer on the calculator, right? I can just put a rule in, graphical rule in, and say, okay, what is it, 3x minus 7, I believe? 3n minus 7. We'll do 3x minus 7 and hit enter. And then I'll just go to the table, Control T, and I'll say, okay, what is the first term? The first term is negative 4, then negative 1, then 2. And I can come over here and say, oh, this is negative 4, negative 1. I can go 2, 5, 8, and I believe the last one would be 11. I'm just counting by threes. Well, I can also do the same thing with this. This is just a sequence. It is an equation rule that will generate a sequence, and I can do a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. And in this case, the rule is defined as 2 raised to the power of n plus 1. So I can just go over to my calculator, get rid of this, Control T. I'll hit the tab button, get rid of the old one. And what is it? 2 raised to the x plus 1. Of course, that didn't work. I hit the wrong button. 2 raised to the x plus 1. And I hit enter. Of course, it's an exponential function, so you should have known it was going to look like that. And then 1 is 4, 2 is 8. So 1 is 4, 2 is 8, 3 is 16 and 32. So 16, 32, 64, and 128. The cool thing is your calculator does it right. You should never get any of these wrong because you have this calculator. And it will help you out a lot. A lot. So to generate a sequence of numbers, that's not too bad. We'll play around with it a little bit more later. Let's talk about summations. I'm going to teach you this new crazy looking thing. This thing is called epsilon. E-P, just about spell it. I always misspell it. It's E-P-S-I-L-O-N. Epsilon. It stands for summation. You're going to do a summation. Wow, summing. I told you this was an easy unit, right? All we're going to do is adding. This thing is a fancy way of saying what we're going to do is add up all the terms of a sequence. So I could have given you this sequence here, and I said, add up the first 6 terms, and you'd say, oh, I'd add up all these. But a fast way to say adding all of them up is to put it in this this capital E, this epsilon format. And I can say, okay, let n equal some number. This is my starting number. Excuse me, start number. And I can go all the way, and this would be my ending number up here. And what I'll put here is some kind of rule or equation. Now this is that rule or equation that's going to generate my, actually I probably shouldn't say equation, I probably should say expression. This will be some kind of an expression that is used to generate the different terms of my sequence. So that sounds complicated, but it's really, really, really not. For example, here's what we're going to do. First thing, the first number is 3, so I'm going to plug in 3. So I get 2 minus 3 times 3, and that's -7. And then I'm going to plug in the next number, and you go all the way till you get to 5. So I plugged in 3. Now I'm going to plug in 4. So 2 minus 3 times 4, and I get 2 minus 12, which is -10. And then I'm going to plug in 5, where I get 2 minus 3 times 5, and I get -13. And then if I added all these up, that would be -30. That's it. Oh, it gets better. Let's say I start here. My first term, my first number is 4. Let's plug 4 in. So I get 4 squared minus 6. Well, 4 squared is 16. 16 minus 6 is equal to 10. Then I'm going to plug in 5. Well, 5 squared minus 6 is 19. 25 minus 6. 6. 6 squared minus 6 is 30. 7. 7 squared minus 6 is 49 minus 6, 43. And finally the last one, which would be 8. Now if I plug in 8, I get 8 squared minus 6. 64 minus 6 is 58. Now let's see. 10, 29, 59, 59 and 90. 59 and 90 is 149. 152. This sounds like 160. But it'd be great if I could check my work. It'd be absolutely amazing if I can check my work and use my calculator to do so. So that's what we're going to do. We're going to use our calculator to check both these. Maybe I didn't add these up right. Maybe I screwed something up. I don't know. Cool thing is the calculator does it for you. Don't tell anybody. We'll go to the calculator. Go to this crazy button right here. We got lots of stuff in there. There's fraction. There's exponent, square root, some kind of root, e, logarithms, bling, bling, bling. Oh, look at that. Epsilon. Click on that. And so you got to define the variable. I'll just call it n. N equals 1. It doesn't matter. And on the first one, it was going till 5. And we're going to type in 2 minus 3x. 2 minus 3. Now I can't use x. In this case, I'm going to use n. Whatever letter you use here, you have to use here. How you hit enter. -35. I'm pretty sure I screwed up adding. Oh, 3 through 5. I think I did 2 through 5. Hold on. Oh, I did 1 through 5. That was really dumb. So we're supposed to be doing enter. Supposed to be 3 through 5, right? 3 through 5. Enter. There it is. -30. And then I'll do it again. Bing. Ding. In this case, it's n equals 4 all the way up to 8 of n squared minus 6. 160. Hey, my math wasn't too bad. So again, calculator does it for you. It's just a quick summation thing. 3 points. Don't see it too often on a reading stove, but once in a while. Let's go back. I think we're here. Scroll down. Oh, here we go again. Oh, I think maybe we got it. So we're going to check them using the calculator. We did that. Boom, boom, boom. So we're going to write the first term So I want to write the first 6 terms of this sequence. So that's pretty simple to do. A sub 1. And you write it as a sub 1 is equal to 1 plus 2, which is 3. A sub 2 is 1, 2 plus 2, which is 4. A sub 3, 3 plus 2, which is 5. A sub 4. So your first 6 terms are 1. Why did I just put 1? Your first 6 terms are going to be 3, 4, 5, 6, 7, 8. That was pretty easy. First 6 terms of this one, we're going to square them. So a sub 1 is 1 squared, or 1. A sub 2 is 2 squared, or 4. A sub 3 is 3 squared, or 9. I think you get the picture, right? So we'll just go and write those in. 1, 4, 9, 16, 25, 36. There's the first and 6 terms generated. Write the first 6 terms of this sequence. Let's see. A sub 1 is equal to 4 to the 1 minus 1. That's 4 to the 0, which is 1, I think. A sub 2 is equal 4 to the 2 minus 1, which is 4 to the 1, which is 4. Uh-oh, it's going to start getting crazy. No, it's not. A sub 3 is 4 to the 3 minus 1, which is 2, and this would be 16. A sub 4 would be 4 to the 4 minus 1, which would be 3. That would be 64. A to the 5 is 5 minus 1 to the 4th power. A to the 6 would be 4 to the 6 minus 1. This would be a to the 6th power. No, 5th power. And this would be a to the 4th power. Let's see. This would be 256. And I think this is 1024. But I can use my calculator. All I got to do is go into graph mode. Probably click out of all the garbage that's there. No, just go back. No. Go back into graph mode. And this was a to the n minus 1, right? So we'll do a to the n minus 1. So x. Nope. I lied like a dog. It was 4 to the x minus 1. And I didn't type that in right. Tab. Up arrow. I got a straight line. I got 4x minus 1. That was dumb. 4 raised to the x minus 1. This should be an exponential function, so it should look like that and very steep. Excuse me. And so when I type this, and when I go to my table, Control T, 1 is 1. 1, 4, 16, 64, 256, 1024. So I was right. Gosh, I love this calculator. It's amazing. I don't know why that's open. So let's get rid of it. Nope. All right, so back to the party. The first 6 terms of this sequence. So this would be 3 over 1, 3 over 2, 3 over 3, but that's 1, 3 over 4, 3 over 5, and 3 over 6, but that's 1/2, right? That's it. Done. Find the 10th term of this sequence. Well, I just got to plug in 10. So a sub 10 is equal to 2 times 10 all over 10 plus 2. So this would be 20 over 12. And of course that reduces to 10 over 6. Let's see. 4 goes in there 5 times, so 5 over 3 if you reduced it. All right. All right, so this one's a little bit different. You see how it's got this 2 out front? What that says is When you're done, add 2 to whatever you come up with. So 3 squared is 9, plus 4 squared is 16, plus 5 squared is 25, plus 6 squared is 36. So that was when I plugged in a 3, plugged in a 4, plugged in a 5, plugged in a 6. And if I add all this up, let's see, 2, that's 25, 50, 86. So 86, and then don't forget the 2 on the front, so 88. Now I'm going to check this. If you don't check these using your calculator, there's something completely mentally wrong with you. So you go in, you hit enter. I'm going to use n. N equals, what was that number? 3 to 6, right? 3 to 6 of n squared. But what was out front? I forgot the 2. Wasn't it 2 plus that? It was 2. Oh, no. It wasn't a plus. I thought it was a plus. It is not a plus. It is a times. So this should be 172. See, I totally screwed that one up. See, this is not 2 plus. There's no plus sign here, so get rid of that. It's actually 2 times this. And since this turned out to be 86, if I do 2 times 86, I get 172. So actually, that's the right answer. Good thing I got that calculator to check things. All right, so this is r to the r. I'm not even going to try this one. I'm just going to use my calculator. We're going to get the calculator to go do this one for us. Those of you at home, if you don't have this calculator, it's kind of tough. So we're going to do summation. Boom. In this case, might as well use r. They said r. Why not use r? R equals 1 all the way up here to 3. Now we got to be careful. This is r raised to the r minus 1. So enter, and we get 12. So that's 12. And, oh, this one's tough. So this is 100 plus, let me just write this down. And we're going to add, now this time it is plus. This is log 10 to the n. This is a base 10 of, oh, excuse me, not n, but n the first time is 2. So of 2. So log base 10 of 2 plus log base 10 of 10 cubed plus log of base 10 of 10 to the 4th. Well, some of you may know this is a 2, this is really a 3, and this is really a 4. And when I add those up, I get 9, so my answer would be 109. Well, many of you don't remember that, oh yeah, log base 10, I don't have to put the 10 in there, of 10 to the first power, it's just 1. And if I do it to the second power, it's just 2. All right, so when I add all that stuff up, I get 109. And again, I would want to check this using my calculator. Why not? Bam. Doesn't take. How long does this take? I forgot the 100, of course. 100 plus. It's kind of important. And going to 2 to 4, 2 to 4 of log of 10 raised to the nth power. And I hit enter, and look at that, 109. How about the absolute value? The absolute value looks pretty tough or pretty simple. I don't know. Which one does it look like? Next one looks kind of tough. Let's see. I'm going to plug in a 4. So remember, we're doing summation. So if I plug in a 4, that's the absolute value of 12. And then I plug in a 5, that's the absolute value of 13. And if I plug in a 6, that's the absolute value of 14. So let's see, that's 25 plus 14, that's 39. I'm not even going to bother. Well, let me check that one. I'll show you that real quick. So that is, let's see. No, that's too much work. So let's do summation. and n equals 4 all the way up to 6. And then where are the absolute value bars? Well, we're going to go back in here, and right here, there are absolute value bars. You remember right here? Absolute value. Here, my dog. Dumb dog. She's crazy. K plus 8. In this case, n plus 8. Whatever variable you use, you probably should use, first of all, the one they give you. N plus 8. My dog, she's vicious. And there's 39. And hopefully we got that. I think we did. All right, the next one is not so easy. I'll tell you what I'm going to do. I'm going to take a look at this cosine curve. So this is 0, 90, 180, 270, 360, and then it's another 90, another one of these, and another one of these. This would be at 4 pi, and this is 2 pi, and this is pi, and this is 3 pi. So every one of these is 3 pi or 4 pi or 2 pi. So let's see what we got here. We're going to do 3 times n equals 0 to 3 of cosine of 0 times pi plus 1. Well, this becomes cosine of 0, and cosine of 0 is 1. So this is 2 plus. Now I'm going to plug a 1 in. Well, what's the cosine of pi? Cosine of pi is negative 1. Negative 1 plus 1 is 0. And then I'm going to plug in a 2. Well, what's the cosine of 2 pi? It's up here. That's 1. 1 plus 1 is 2. So I plugged in a 0, I plugged in a 1, I plugged in a 2. Now I got to plug in a 3. Well, the cosine of 3 pi is negative 1. Negative 1 plus 1 is 0 again. So this just turns out to be 4. And I wonder if I can get the calculator to do it for me. Now, unfortunately, let me go into document settings and change mine back. If yours is in degree, mode, and you try this, let's see what happens. So let's use n. And what did we start out with here? N equals 0, 2, 3. Uh-oh, I forgot the 3 out front. Gosh, why do I keep forgetting to do that? I think I even wrote it down over here. I got the 3 out front here, so 3 times what I came up with. So this should be 12. Let's see if we get that. So 3 times. Now we're going to do cosine of n times pi plus 1. I wonder why. The reason is this is in Radian mode, and in order to do this, you actually have to be in Radian mode in order to try that. So if I did this same thing, and I hit enter, and I get 12. That one's fun. All right, let's keep going. What do we got next? Arithmetic sequences, right? Got a little sequence and series now. All right. Arithmetic sequence. In an arithmetic sequence, the common difference of consecutive terms is constant. It's called the common difference. You're looking for things that add up. So what we want to do is see if there is a common difference. If I subtract these, negative 3 minus 5, I get, that'll get me into trouble. It's negative 3 minus, okay, I'm not going to be able to write this right apparently. Let's try it in black. Negative 3 minus negative 5. Well, that's positive 2. And then if I take negative 1 and subtract off negative 3, you're really adding. That's positive 2. So in this case, if I take any one of these, 3 minus 1, it's positive 2. So the common difference is 2. So yes, this is an arithmetic sequence. Over here, 27 minus 32. Well, that's negative 5. And then 21 minus 27, that's negative 6. And 17 minus 21, that's negative 4. This is not an arithmetic sequence because it doesn't have a common difference. If I subtract these, that's 2. If I subtract these, that's 4. If I subtract these, that's 6. No. So you're looking for a common difference. And what our goal is to do is to be able to try to create an equation or a sequence rule, a rule for writing an arithmetic sequence. An arithmetic sequence is just a sequence of numbers that has a common difference by adding and subtracting. So the nth term, and here's the equation. The nth term of any sequence is the first term. This is the first term. This is the term number you want, term number, multiplied by the common difference. So let's say I take the numbers 5, 10, 15, 20, 25. Clearly their common difference is 5. So then my D would be 5 in this case. So if I start out with 5, and really what I want to do is I want to multiply n minus 1 times 5. Well, for the first one, remember this is number 1, I don't want to multiply by anything. I don't want to add anything. Excuse me, not multiply. This would be plus. This would be plus because it's an arithmetic one. Arithmetic is always adding. So you're going to take 5, and then 1 minus 1 is 0. 0 times 5 is 0, so that would go away, give me 0. Then basically what you're going to do is add on another 5, and then add on 2 5s, then add on 3 5s, then add on 4 5s, then add on 5 5s, and that's how you're going to keep generating the sequence. So we want to find a rule for the nth term of these numbers right here. So first things first, common difference, 7, 7, 7. So my D equals 7. So now I'm going to write my rule. A sub n is equal to, oh yeah, I should also write down my a sub 1 is equal to 2. This is kind of the work you need to show. And that's we're going to do a sub 1 plus n minus 1 times D. Generating the sequence one number after another. So we'll start with 2 and we'll add on n minus 1 times 7. So in other words, this is 2 plus 7n minus 7. So my final rule that I want to come up with is, I didn't leave myself room, a sub n is equal to 7n minus 5. And that's my rule. And then the question says find a sub 19. Well, a sub 19 is pretty easy now. I just do, okay, a sub 19. I don't like a's. They look too much like 9s in my case. 7 times 19 minus 5. And 7 times 19 is one of those obnoxious multiplying. 7 times 19 minus 5. 128. And we're done with that. 128. So this stuff's not difficult. We're looking for a common difference here. Common difference, 8. Common difference, 8. Common difference, 8. But remember, to find it, you take the second term, a sub 2, and you subtract off a sub 1. In this case, that's 45 minus 57. So my common difference is really, really negative 8, because I'm coming down by 8 every time. So I'm ready for my rule. A sub n is equal to my first term, which is 57, plus n minus 1 times the common difference. Well, if I distribute that common difference, I get a sub n is equal to 57 minus 8n plus 8. And I'm finally going to write it. A sub n is equal to negative 8n plus, what is that, 65? 65. And they want to know a sub 19. All right, I plug 19 in. Totally forgot what it was. Negative 8 times 19 plus 65. Negative 87. So this came down and equals negative 87. Gotta love that calculator. All right, let's go. Coming down by 4, coming down by 4, coming down by 4. So my common difference is equal to negative 4. My a sub 1 is 9. Therefore, my formula is a sub n equals my first term, which is 9, plus n minus 1 times negative 4. All right, so you're going to have to distribute. So you get 9 plus, well, that's going to end up being minus, actually, because when I distribute this negative, I will get 9 minus 4n plus 4. See how I'm distributing? So my final equation here is a sub n is equal to negative 4n plus 13. And to find a sub 19, like they asked, all you do is this, negative 4 times 19 plus 13. Let's see, 4 times 19, 3876. What is that, negative 63? I can check it. Why not? Negative 4 times 19 plus, totally forgot, 13? 13. Negative 63. Oh my gosh. The math is just unbelievable. Let's see. Oh, these are hard. So we're going to take the second one, negative 9. Subtract off the first one, negative 15. But we're subtracting a negative, so we're really adding. So negative 9 plus 15 is 6. So there's my common difference. And don't these have a difference of 6? Add 6, add 6, add 6. So my equation is a sub n equals my first term, which is negative 15, plus n minus 1 times 6. Distribute, I get a sub n equals negative 15 plus 6n minus 6, or a sub n equals 6n minus 21. So if I plug in 19, a sub 19 is equal to 6 times 19 minus 21. So I'll come over, 6 times 19 minus 21. I hope it was 21. 93. All right, we're almost done, kids. 2 left. One term in an arithmetic sequence, a sub 11, is 41. The common difference is 5. Write the rule for the nth term. Let's see. How are we going to do this? Excuse me. So really what I want to figure out is I got a sub n is equal to a sub 1, which I don't know, plus n minus 1 times 5. Well, I know a bunch. I don't know this. I could just call it x. Why don't I just call it x? I know a sub n. A sub n is 41. I also know that n is 11. So 11 minus 1 times 5. And that would give me 41 equals x plus 50. Subtract 50, I get negative 9 equals x. So I'm going to guess my equation then, now that I have my x, which is my a sub n. I probably shouldn't have called it x. That's probably not a great name for it. I probably should have called it what it really is, and that's a sub 1. A sub 1. a sub 1, because that's what you're looking for, a sub 1. So now I've got a sub n is equal to my a sub 1, which is negative 9, plus n minus 1 times 5. All right, last one. So a sub n equals a sub 1 plus n minus 1 times my common difference. So I know this is 107. I have no idea what this is. Plus, I know that n is 15 and d is 12. Well, this turns out to be 14 times 12. So come over here, do 14 times 12. Was that 168? 168. So I get 107 equals a1 plus 168. Subtract 168, and you get negative 161 equals a sub 1. Or my final equation is a sub n is equal to negative 161 plus n minus 1 times 12. And that's it. Arithmetic sequences. Geometric sequences are next. A little bit of recursion and we're done. All right, kids, nice job. Take care. If you like what you see, hit subscribe. Please hit subscribe. I need some subscribers.